Welcome everyone. In chemistry, we have esters. For example, this is an example of ester. Now, this ester can be changed to a different form. For example, if I'm having ester such as CH3, I can decide to change this ester into a different type of ester. For example, now I'm having a type of ester, this one here, and I can decide to change it into this type of ester through a concept known as transesterification. Now, in this video, I'm going to discuss about how transesterification occurs and the conditions under which a reaction leading to transesterification can be performed. Now, imagine a situation whereby I'm having my molecule, and for this reason, I want you to be very attentive here. Transesterification can occur in two ways. One, that is acid-catalyzed, and the second one is transesterification, that is base catalyzed. Now, I'm going to discuss acid-catalyzed transesterification in details and even the reaction mechanisms involved. So to begin with, I'm having my ester. My ester here is going to be R to represent the carbon chain. Then on the other hand, I'm having oxygen bonded to R pi. Then as my ester. And in first stage, step 1 of transesterification, step 1, I'm going to do protonation. And how is this one going to occur? It is a reversible reaction. So I'm supposed to protonate my first ester. And since it is acid catalyzed, and I'm doing it using water molecules and also alcohol, so I'm going to have a situation whereby I'm having hydronium ion that is bonded to partial positive charge. So in the first stage, I'm going to protonate. So what you need to know is the lone pair of electrons found here are going to attack or to grab that hydrogen, Then an electron is shifted back onto that oxygen. And now I'm going to have my protonated sample, which is written as R. Then on one side I'm having OR pi, then double bond O, hydrogen with the positive charge, then lone pair of electrons. Now from this stage I'm moving to my step 2. In step 2 I'm having nucleophilic addition. Now I'm having alcohol in my sample, and the alcohol, I'm going to pretend that the carbon chain of the alcohol is going to be R pi 2 bonded to OH with the lone pair and a lone pair at the bottom. So in this stage, our alcohol is going to act as a nucleophile. It is going to donate electron pair. When that happens, the double bond opens up on oxygen, and the sample that I'm going to form is R, that is first bonded to O, that is first bonded to original OR pi. Then I'm going to have oxygen that was bonded to hydrogen, and on one end I'm having R, then with a partial positive charge on top. Then on the other end I'm having oxygen with its two lone pairs, H. Now when that happens, I'm moving to my step 3. I'm moving to my step 3, and step 3 is going to be still a reversible reaction. Still having my alcohol in the solution. And what you need to know about step 3, now in step 3 I'm having proton transfer occurring. And how is that occurring? What is going to happen here is very simple. The lone pair of electrons found on that is going to pick this hydrogen, and an electron is going to be shifted. When that happens, I'm going to form a new product, and my product is going to be R, that is bonded to OR pi, that is bonded to OR double pi, and on the other side I'm having OH with the two lone pairs of oxygen. This one has a lone pair and a lone pair, a lone pair and a lone pair. You have to take that into consideration. Now in my step 4, Step 4 of my reaction. Step 4. The reaction that is occurring is still proton transfer. Now, in my proton transfer, the oxygen bearing the carbon chain that I want to replace is going to react with the alcohol in question here. So I'm going to have R double pi OH. So if I'm having that in solution, what is going to happen? The lone pair of electrons found here, these ones, but let me draw it correctly, the correct way, so that we can see what is happening. Let me bring the displayed form of it in a clear way. So now I'm going to have R double pi. Now I'm going to have a situation whereby it is bonded to oxygen that has a hydrogen and another hydrogen with a partial positive charge. Yes. Then what is going to happen here? That hydrogen is going to be picked and an electron is going to be transferred into that system. So when that one happens, the product that I'm going to form here is an intermediate where I'm having R that is bonded to an improved form because we picked hydrogen. So I'm going to have a O H R partial positive charge. Then the other end was O R. Then at the top you are having OH with that. The reaction is still going on. So if you compare the OH, this OH here, and this OHR, the best leaving group is OHR because it is having a partial positive charge. So the molecule can reorganize itself to ensure that OHR is eliminated. So in my step 5, we're going to talk about elimination of OHR. Now, what is going to happen here? One of the lone pair of electrons found on oxygen is going to be shifted into the molecule. So what is going to happen? We are going to have a situation where that is going to happen. Then this one is going to be expelled. OHR. So our OHR here can also be called an alcohol. Always remember that. Now, when I get to the next thing that I'm forming, I'm going to form a new product, and the product is going to be influenced by an alcohol that is still found in the solution. So what is going to happen? I'm going to form a situation whereby I'm having a double bond. For example, R, I'm having R. That is on the other side, I'm having OR. Then on this side, I'm going to have a double bond, but the double bond now is having oxygen that is bonded to a hydrogen with a partial positive charge and a single pair of electrons. Now, when that happens, we need to remove a hydrogen here. So the lone pair of electrons found on this, going to pick this hydrogen. When that is picked, an electron is shifted there. Now, at the end of the day, the product that I'm going to form is this. The product I'm going to form is R O R, then a double bond O with only two lone pair of electrons. So what do we say? This is my new ester that has undergone transesterification. So if we check very well in that reaction mechanism, we started with ester that had O R pi. So at the end of the day, we are finishing with an ester that has O R double pi in it. That's now our new ester. And the reaction took place in the presence of an acid. So it is acid-catalyzed transesterification. Thank you very much.